Section 2. We've talked about sets. We've talked about what we are. Now today in section 2 and section 3, we're going to talk about relationships with sets. We're going to talk about operations with sets. We'll have a little bit of fun. So you see at the top of the page, I have defined a set for you. It's just a nice, simple, relaxed set. It's got 6 things in it, A, B, C, D, E, F. You don't need to write this down because it's already on your page, but I'm writing it down so that everybody can see it. What we're going to talk about now that we know what sets are in section 2 is we're going to talk about something called a subset. Okay. Prefix sub means below. So how does that apply to our idea of a set? So the definition of a subset is this, and this is what we're going to practice with for a while. We're going to try to get a visual on what subsets are. So this is my set. This is my set A. Then I can create something called a subset. Okay. Set B, this marker doesn't want to work, is a subset of set A. Okay. So we're going to create some subsets of set A according to the following definition. Set B is a subset of set A if and only if every element of set B is an element of set A. Give me a minute to fill in that blank. So anything that I can create from this set that we would label a subset is just going to be something that every element of my set B is an element of set A. So I have a few examples right below that definition. But before I do, I don't want to skip over the notation for a subset is like this. We would say then B is a subset. It's kind of a U that's on its side with a little equal sign below it. B is a subset of A. All right, so I have some in it, the exercise. I have 5 sets listed, and we're going to determine are they a subset, yes or no. I haven't used the letter B just because there's nothing particularly special about using the letter B here. So we've got different letters. So I'm just going to real quick write these down. So please be patient with me. So set B has B and D in it. Well, let's start there. That way you don't have to watch me. I'm going to do this example with you, and then you're going to do the other ones. So the definition of a subset means I have a set here. Is everything in this set in the original set? Yes. I've got a B and a D here. There's a B and a D there. So what we can say then is this set B does qualify as a subset of A. It meets that relationship. What I'd like you to do now, I'm going to write these next problems on the board, but go through sets C through F and make a determination. Are each of those a subset, yes or no? Okay, different answer for each of them. Oh, that's a fantastic question. It's kind of, so in case you didn't hear it, what's the symbol if it's not? What you do is kind of like with a not equal, you use your subset symbol and then go like that. Okay, so if you need to notate that. Great question. Appreciate that. Right, so the definition, I've erased it, but it's on your paper. The definition of subset is everything in the set we're looking at. It's a subset if everything in the set we're looking at is part of the other set. So C is A, D, F. Is everything here in set A?
Yes.
Yes, ADF. So C is a subset of A. Great job. You're doing great. If you have any question about why or why not something is true, let me know. The next one, D, AEIOU. Is that a subset of A?
No.
Why not?
There's no I.
Yeah, there's no I, there's no O, there's no U. It fails on a couple different levels there. So as you asked, and it was a great question, we're just going to write not a subset of A. Wonderful. E, is E a subset of A? Is everything in E also an A?
Yes.
All right, so yes, E is an A. You probably already noticed when you were doing this that also E is actually the same thing as A. So I just want to make mention of this as far as the notation is concerned. Do you remember in arithmetic using this symbol? 5 is less than or equal to 5. Right? Is this a true statement? We got a little equal bar here. Okay, you might be confusing with this statement right here. Is this a true statement? Is 5 less than 5?
No.
No, that's false. Okay, but if I put a little equal bar right there, this now means 5 is less than or equal to 5. So this now is a true statement. So the same thing is true with my subset symbol. This little bar down here at the bottom means equal. So even though this is the exact same set as this, it still is a subset. Yes, sir. What's your question?
I was just gonna say, how is it equal?
Well, the symbol means less than or equal, so it offers you a choice. Okay, so that's so when you read this, you say 5 is less than or equal. It meets one of those two criteria. This one, when you don't have the equal sign, doesn't give you the choice. It's just 5 is less than 5. That's why that one's not true. Okay, just for kicks, you can impress your friends. As far as inequalities, this is called strict inequality because you don't get a choice. This is called a weak inequality because it does give you a choice. So there you go, a little trivia for you. You don't need to know that, but want to give you your money's worth. This might be one that surprises you. Okay, set F. F is an empty set, and so you might be tempted to say, well, okay, F doesn't have anything in it, so it's not a subset. So here's the thing to remember. You're right, F does not have anything in it. So hence, by logic, everything in here, which is nothing, is also in here. Okay, now if that bothers you, okay, which I understand that can give you a headache if you think about it too long, just remember that the empty set is a subset of anything. Okay, any other set. This is always true that if you have an empty set, it is always a subset of your set. Okay, you never have to think about it. Before we move on to the next bit of trivia from this section, okay, there's really only 2 things we're talking about in this section, and we have some fun demonstrations. Any question about these 5 examples so far? All right. Well, we've talked about a subset, and I talked to you a little bit about the notation of the subset. The next thing is we're just going to add an extra little detail in here because math people like details of what's called a proper subset. And so we would say set B is a proper subset of set A if it's a subset, but then it has fewer elements. So I'm just kind of summarizing the definition that's on the page. Okay, the definition on the page says set B is a proper subset of set A if and only if every element of set B is an element of A, which is what we already saw, and set B is not equal to set A. So a proper subset is a subset with fewer elements. So this is kind of a shorthand way to think about it. A proper subset is a subset with fewer elements. So please do this for me. Same 5 examples. You've already determined if they're a subset or not. Now I want you to go through and determine if they're a proper subset. And I should mention, if I was a better instructor, I would be better at this. The symbol for proper subset is, we just lose the equal sign now. It's just this U on its side. Okay, no more equal sign. So I'm going to give you a minute or a minute and a half to think through those 5 problems. Are they proper or not? So a proper subset is a subset with fewer elements. Here goes. Set B is B and D. We already said it was a subset. We already know that. Is it a proper subset? Yes, it has fewer elements. Perfect. So I'm going to put a U on its side right there. That's the symbol. Set C is ADF. We determined the first time around it was a subset. Is it a proper subset? Again, yes, fewer elements. So there we go. D we determined before was not even a subset, so it can't be a proper subset. So we're going to put the same symbol. E, A, B, C, D, E, F. First time around we said this is a subset. Everything in here is in there. But is it a proper subset? No, it's the equal set. Okay, and that's what we were talking about when we were looking at the arithmetic symbol less than or equal to. There's no equal bar on a proper, so since those are equal, we're going to put not a proper subset there. So it can be one but not the other in the case of that set. And then finally, I mentioned to you already, the empty set. The empty set is a proper subset because it definitely has fewer elements than the original set. Any questions about any of those? What I would like you to do, the next exercise, I gave you a new set A, the numbers 1 through 17. Just as an exercise to think about this the other way, just on your paper, write down two proper subsets. It doesn't matter what they are. Somebody give me one of your proper subsets. What do you got? 1, 3, 5. Fantastic. Everything in here is in here. That makes it a subset. It has fewer elements. It's proper. Somebody else said something too. 111. Great. Same thing. Everything in here is in there. It's smaller. Let's go a couple more. Wonderful. And another one? In fact, the only subset that you could have done that would have been wrong is if you did the whole equal set, because I asked for proper subsets. So if you're looking at your paper and you want to know, did I get it right or not? I'll check it after class, that's fine. But if you want to know, as long as you have some assortment of these numbers, but not all of them, you got a proper subset. Okay, so that was fantastic. All right, we're going to flip the page now. We've got this idea of what a subset is, what a proper subset is. We're cruising right along. So another exercise. Again, just reinforcing this, making sure that when you leave here today that you feel totally confident when you go to engage your homework. So it's that same set A, and I've given you 6 different sets, and I want to know, is each of those sets a subset, a proper subset, or neither? So you might have 2 answers. You might have 1 answer. You might say neither for each of those sets. So give it a try. Please. going through each of these. First one is B. First, I'm going to ask, is it a subset? And then we'll determine if it's a proper subset from there. That will be our secondary question. 3, 11, 13, 19. Is B a subset of my original set?
No.
Why not? The 19. The 19 is not in the original set, so B is not a subset of A. And then B is also not a proper. If it's not a subset, it can't be a proper subset. Okay, it has to be a first subset. Okay, any questions about that first one? We're okay so far? So the answer to that one will be neither, but I just wrote out not for both those. All right, C, 1, 3, 9, 11. Is this a subset of A? Yeah, everything in C is in A. Is it a proper subset? Yes, it's got fewer elements. Fantastic. You're doing a wonderful job. If you have any question at all, please let me know. So that, again, I want you to feel totally good about this when you leave here. This set right here with 13 in it, is it a subset?
Yes.
Yes, and then clearly it has fewer elements, so it is also a proper subset. Fantastic. E, is E a subset of A? No. There's no 16 or 18. We skipped those over there. That's okay. You're still dealing with those hiccups. So 16, 18 is not a subset because those numbers are not up there. So it also can't be a proper subset. So that one's a neither. Empty set. Is empty set a subset? Yes, that's our good friend. So it's also a proper subset. Wonderful. And then last but not least, G. Is G a subset of my original set? Yes, it is. Is it a proper subset? No, it's not. It's the equal set. Perfect. Excellent. Just a quick review of what we've talked about so far. So before I move on to the last thing from section 2.2, is there any question about any of these problems right here? So the question, I'm sure you're thinking this seems interesting. And when we wrote down subsets of set A, when we were choosing, there seemed to be a lot of choices. And so how many subsets can I actually make from a set? And that's a great question. I'm super glad that you asked it. So how many subsets are there if I'm given a set? So that's a great question. So what we're going to do, and you're going to help me, is we are going to look at and see if we can find a pattern and determine the answer to that question. Okay, how many subsets are there? So we're going to do this. We're going to start nice and small. We're going to start with a set with one element in it. So it's set with one element. I just use the letter A. There's nothing particularly special about it. So the set with just A in it. That's my one element. So what we're going to do is we're going to list out what the subsets of this are. Somebody give me a subset of this. A. Sure, the equal set. Is there another subset? The empty set. There's my list. How many subsets does that make? 2. Well, we'll come back to that in just a minute. Now we're going to move on. Okay, so we're going to look. We're going to compare. One element. There were 2 subsets we could list, and there they are. Okay, the next one is we're going to start with a set with 2 elements. And just for convenience, I picked A, B. So now we're going to list the subsets of that. So help me out. What's the first subset? Or it doesn't matter, it doesn't be first. What's the subset you see? A. Okay. B. Yep, heard B. Yep, AB, great. Or BA, remember we talked last time that for sets to be equal, they only have to have the same elements, it doesn't have to be the same order. So if you had written down BA, it's fine. I'm just an alphabetical order guy, and when we get to the next section, you'll kind of see why that helps us when we're doing problems. And then the last subset that we can find is, okay. How many subsets is that? 4. Just to make the pattern even more obvious and we can be more certain of this, we're going to do this one more time with 3 elements. So sometimes this is how math is done. Math people look for patterns in things and then see, is that just a coincidence or is that something that really happened? So you are going to use some inductive reasoning here in just a minute. Okay, that's a higher level math skill, so that's a good thing for you today. And so how many subsets are there of this? Well, let's list them out first. So give me some subsets. Okay, we've got the A, and then I'll give you the B, and then the C. We've got the sets with 1 in it. What else do we have? Yep, AB, BC. Sure, AC, that sounds great. We're getting close to the finish line. We've got all the subsets with 1, all the subsets with 2, and then we have what else? And then last but not least, the empty set. That is fantastic. You are 100% right. How many subsets is that? Excellent, 8. All right. So we've done that exercise. Now let's use our reasoning skills. Let's look at what happened. When I had 1 element, we had 2 subsets. When I upped it to 2 elements, now there are 4 subsets. When I upped it to 3 elements, there are 8 subsets. What do you notice is happening every time I add another element? It's multiplying by 2, right? It's doubling. So we went from 2, 2 times 2 is 4, 4 times 2 is 8. So if I asked you to do this, which I wouldn't because I'm not into math torture, okay, but if I said, how about if we had a set with 4 elements, A, B, C, D, we're not going to list it, but how many subsets would you say there's going to be? Perfect, you're just following the pattern. Excellent work. That is deductive reasoning. You're doing a great job. Okay, so we have our subsets. So now, is there a way that I can say this in general? And so then the answer is yes. Okay, we don't have to go and list things out and see this. There is a general pattern here, and I'm going to show it to you. I had 1 element. There were 2 subsets. 2 can be written as 2 to the first power. When I had 2 elements, there were 4 subsets. 4 can be written as 2 to the second power. 2 elements, second power. 3 elements, there were 8 subsets. 8 can be written as 2 to the third power. So what's happening every time with my number of elements? What am I doing with this number? It becomes what? It becomes my exponent. 2 to the second, 2 to the third, 16 is 2 to the fourth. You can use your calculator to verify. So how many subsets are there for a given set? Well, the answer to that is there is always 2 to the n power. However many elements there are in the set, it's 2 to the n power. I told you last time that for this class, all you need is some sort of scientific calculator. That would really be the maximum thing you need. And so if you have one and you don't know how to evaluate exponents on it, just see me after class. It'll take us literally 5 seconds to find the exponent button and for me to show you how to work it. In the meantime, the next exercise says, how many subsets would a set with 8 elements have? So write it down, use your calculator, make sure that you can verify what the value is going to be. All right, how many subsets are there for a set with 8 elements? Okay, and where did you get that? It's 2 to the 8th, and then you just put that in your calculator. 2 times 2 is 4, times 2 is 8, 16, 32, 64. That's 2 to the 6 is 60. 2 to the 6 is 64. We got to go a little further, and then 64 times 2 is 128. 128 times 2 is 256. Okay, verify on your calculator. Before you leave here, I want you to feel good that you can use your calculator to evaluate an exponent, 2 to the 8th power. If you can't, like I said, there is no shame in that. There's no shame in admitting that. But please let me know so that I can help you be able to do that with no problems. Last problem on the sheet that I gave you. It's kind of a rather simple application of this idea of subsets. So these things do have, in certain contexts, they do have application. So this problem is going to be an example of the number of choices that you can make for something. You'll have a few problems like this exercise in your homework. So what we have the people, Fitzgeralds, they are installing an in-ground pool in their backyard. Great. They can install the base model offered by the pool company. And then that could be it, but then they could also choose to add any of the following options, okay? So I'm just going to, for this exercise, I'm gonna list out the options, okay? This is the set of options that the pool company offers. Okay, I'm gonna do a little abbreviating so that you don't have to watch me write down these words. Okay, we got the pool cleaner. Okay, we've got a solar cover. We've got a waterfall, that sounds cool. Hot tub. Got a fountain, slide, diving board, and that's it. So what we want to know is, if you're the pool company and you want to sound impressive and you want to say to people, this is the number of different types of pools that you can have installed by us. How many total different choices are there for the Fitzgeralds to install their pool? Okay, there's 7 elements. But there's more than 7. There's more than 7 choices they have, because they could pick just to have the cleaner put on, right? There's choice 1. Does that make sense? Okay, they could pick to have the solar. That's choice 2. But what if they had other combinations? What if they said, hey, we're feeling really interesting. We want a waterfall and we want a slide. So they are picking some subset of the choices. So there's going to be more than 7. There would be 7 if I could only pick one of them, but I could pick 2. I could also pick these people could also pick 3. They can say, hey, we want a cleaner, and we want the solar, and we want a slide. So the options they pick are some subset of the original set. What if they chose to go with the empty set? What does that mean they're doing when they buy the pool? They're just getting the pool. They are denying any of these options. They just want to be able to jump in the water. Okay, so this is a subset problem, is what I'm trying to point out to you. So one of the applications of this principle is this tells you how many choices you have in a certain situation. And so the pool company can say, well, this is how many choices, this is how many different varieties of pools we have. Well, how many subsets? How can I calculate how many subsets there? Perfect. Okay, so there's 2 to the 7. And now in your calculator, what is 2 to the 7? 128. So there are 128 different options for pool accessories that they could possibly have. And that is that. That is our section on subsets.